Okay, the limit definition of continuity is as follows. And so for this condition to hold, we have to show three conditions being satisfied. That is, first of all, that f of x must be defined at the point x equals a. We have to show that the limit exists, and we have to show that the limit and the value f of a are one and the same. So a function will fail to be continuous when any one of these conditions fail to hold. So we're going to apply this limit definition of continuity to two problems. Okay, first of all, we have this function here, and we're asked to determine whether the function is continuous and or differentiable at x equals 8. And so as we look at the three conditions, first of all, we see that f of 8 is 0. So clearly the first condition is satisfied. The second condition, we have to show that the limit exists. So the question is, does the limit as x approaches 8 of f of x exist? That's what we're trying to answer, that question. One way to do that is to graph the function. In the case where it's a simple rational function like this and you really can just sketch it, that is the path of least resistance here. Okay, you could also, as the example that we've done previously in class, you can make a table, and we'll do that for the next example as well. But if you can ever sketch a graph, it will yield some insight into the limit. So here we can see that as we approach 8 from the left, right, the limit goes to negative infinity, right? So our curve is approaching negative infinity. And when we approach the vertical line x equals 8 from the right, we see that the curve continues infinitely upward towards positive infinity. And because those are different values, the left and right hand limits are not the same, then the limit does not exist. So the answer to our question, does it exist? The answer is no, because the left hand limit, which we said is coming in from the left, is negative infinity, and the right hand limit, which we said reaches or is continuing on to positive infinity, are not equal. So because those two limits, because the left and right hand limit are different, then we say no, or not equal. Okay, and then finally 3, the third condition, we need to compare f of 8 and the limit as x approaches 8 of f of x. And we're trying to see, do they equal? Okay, so in answering the questions, are they equal? We look at 1 and 2, right? And f of 8 is 0. And the limit of the function as x approaches 8 does not exist. So, does not exist. Because they are conflicting, then we conclude that condition 3 fails, right? And so here, this right here fails, and really 2, the limit does not exist, so that fails. So 1 was met, 2 and 3 fail, okay? And then finally, the statement at the bottom here says the function f of x is not differentiable at x equals 8 because there is no tangent line. Now, talking about this whole tangent line thing, with a tangent line, remember graphically what we said with a tangent line. Tangent lines measure a rate of change of a curve, right? So we're talking at x equals 8. So clearly, there is no tangent line to a point because there's no change of a point, right? You can't draw a secant line. So therefore, there is no tangent line. Okay, and so one more example. We have here another function to consider, and we are going to ask ourselves the same three questions. Okay, first of all, for this function, we are looking at the limit of f of x as x approaches 5. First of all, we have to evaluate f of 5 to see if that in fact exists. And so plugging in at f of 5, we find that that is 7. Okay, so condition 1 is met. Condition 2, right? We want to see, does the limit exist? And so let's ask ourselves, does the limit exist? Now remember, for the limit to exist, the left and right hand limits have to be the same. So we can see here that as x approaches 5 from the left, it approaches 0, okay? And not as, right? And then as x approaches 5 from the right, we also get closer to 0, okay? Again, just by looking at the function there, okay? So clearly the limit does exist. So the answer there is yes, it does exist because the left and right hand limits are the same. And then finally for the third condition, so we're good so far, right? So here 1 and 2 check out, so far so good. We get to condition 3 and we need to compare, right, 1 and 2. So here we need to compare the limit as x approaches 5 of f of x, which we found to be 0, right? We're going to compare that to f of 5. We found that f of 5 is 7 because these two values are different, because they are not equal, right? Then we say that condition 3 is not met.